Hello guys, welcome to Ramta Solutions. Today we're looking at your trig graphs, and to be precise, we're looking at your sine graph. So at the end of this video, you will understand why we say A is the amplitude and B represents your scaling and number of waves, P horizontal shift and Q your vertical shift. Okay? At the end of this video, you will understand these things. So without any waste of time, let's get into it. Okay, so first thing first, maybe let me say f of x equals a sine bx plus p plus q. All right, perfect. So we are saying this a represents the amplitude, right? It represents the amplitude. So this is basically the height of a wave. Okay, height of a wave. Okay, this is height of a wave. Okay, height of a wave. I don't know if I should call it a full wave, but yeah, it represents height of a wave. Okay, so from its equilibrium position or depth, maybe depth, even depth is still okay. All right, then we then head to this b. This b, it represents two things. One, it looks at the scaling factor. Okay, it is the scaling factor. So basically what we mean is that when you plot your graphs, especially your tree graphs, sometimes you don't you're not sure if you should maybe scale it with your 90s, 30s, 45s and so on, right? So better to look at the value of b, and you will say, so your factor or your step, your calculator says step, it'll be 90 degrees over b. So if b is 1, you must make sure that your step is 90 divided by 1. Your step is 1. If it's 2, your step is 90 divided by 2, which is 45, and so on. Okay? So this will help you when you draw, and even on your calculator when you're using the table option. Number 2, this b, what it represents, it also represents the period. Okay, it also represents the period. So the period is basically saying to us, when do we experience a full wave? Okay, when do we experience a full wave? For sine graph, you use the formula 360 degrees over b. Okay, remember a full wave is when you have a maximum and a minimum. Okay, you will see that later. So for you to know when you're experiencing a full wave, you will say 360 over b. Therefore, this means when b is 1, you will experience the full wave at 360 divided by 1 at 360. When it's 2, divided by 2, meaning at 180. When it's 3, divided by 3, meaning at 120, and so on. Okay, so this is what this b represents. Okay, so I'm saying it represents the period, but maybe thirdly, I should also tell you, it also means number of cycles. Let me call it number of cycles. Okay, it represents number of cycles in the domain. X is an element of 0 degrees to 360 degrees. Okay, so what it means if your b is 1, it means in this domain 0 to 360 degrees, you have 1 full cycle. If b is 2, it means you have 2 full cycles. Okay, if b is 2, it means you have 2 full cycles. If b is 3, it means you have 3 full cycles. And obviously, you can know when you, for you to know when the first cycle is obtained, you just use the period. Okay, remember this period used in maths, it also has the same meaning in your waves in physical sciences. Okay, but let us not get too technical. Some are not using, I'm not doing physical sciences. All right. Now let's look at the P. This P represents what we call the horizontal shift. Let me just squeeze it here. Represents what we call the horizontal shift. When P is positive, graph shifts left. When P is negative, graph shifts right. Okay? Graph shifts right. Okay. Graph shifts right. Okay. Now, further, we will then look at Q. This Q, first thing first, it represents two things. One, it represents the equilibrium position. Okay, it represents the equilibrium position. Let me move it slightly. It represents the equilibrium position. I will explain to you what we mean by that. It represents the equilibrium position. So, this is the line that divides the maximum and the minimum in equal lengths. Okay, it is the line that divides maximum and minimum points in equal lengths. Secondly, it represents the vertical shift. Okay, it represents the vertical shift. Okay, it represents the vertical shift. I like drawing these arrows. I know they have different meanings, and for horizontal I like drawing these ones. So it represents vertical shift to say, now when Q is positive, it shifts up. When Q is negative, the graph shifts down. Okay, when Q is positive, the graph shifts down. So these are what these parameters mean for our function. And be careful here, this P value is in degrees. Okay, it's in degrees. It is not in any number, it's in degrees. This Q, since it's a Y value, it's a simple number. Okay, perfect. So now let's now look at how to find your minimum and maximum. Okay, let's look at minimum and maximum values. Minimum and maximum values. Minimum and maximum values of our tree graphs. So for when A is positive, this graph looks like this. When A is negative, this graph looks like this. It looks like this. Yes, it looks like this. Yeah, it looks like this. Yes. So what we have now is this. When we are looking for the minimum and maximum, what we're going to do, we're going to say when A is positive, remember, minimum would be negative A plus Q. Remember, the value of A plus the value of Q. Okay, perfect. Now, to find the maximum value will be, this is the highest point, right? It will be value of A plus value of Q. Okay. Now, when A is negative, the minimum value will be negative. It'll be A plus Q, while the maximum will be, maybe I should write equals, not this, because it's min and max. So when A is negative, maximum value will be negative A plus Q. Can you see that? So these are the things that you need with regard to your thingy, your minimum and maximums. You don't necessarily need to know them by heart, but through practice you will get to know them. Now, I will not talk about the domain of this function, but I can talk about the range. Okay, I can talk about the range. So let me just add the range. So when we talk about the range, let me add the range here. I'm gonna add the range. When we talk about the range, we'll say y is an element of included. Where does it start? At the minimum, right? At a minimum, which is minus a plus q. And where does it end? At the maximum, a plus q. This is when a is positive. When a is negative, our range, we say y is an element of a plus q. It starts at a minimum, right? Ends at negative a plus q. Okay? And ends at negative a plus q. So this is how you find your range, your minimum, and your maximum. Okay. All right. Now let's try examples. I will say draw 1, f of x equals sine x. 2, g of x equals sine 2x plus 2. All right? Now, also state 1, min and max values. 2, range. By the way, this is for the domain x is an element of 0 degrees to 360 degrees. Okay? This is for the domain x is an element of 0 degrees to 360 degrees. Okay? So, I think this is all that we need. Now, we can start this by maybe manually stating all these before we can draw them, right? Before we can draw them. So let's begin with y equals f of x equals sine x. Check this out. F of x equals sine x, and here let's take g of x equals sine 2x plus 2. All right? So obviously the amplitude for this one, amplitude is, remember, the coefficient, the value of a here is 1, so it's 1. What about here? Amplitude is still 1. Amplitude is still 1. Right? Now let's look at the minimum. What is the minimum? Remember, minimum is a plus q. So what is it? Minimum is, what is the value of a? It's 1. What is the value of q? It's 0. So minimum is 1. And here, what is the minimum? Minimum is, value of a is 1, the value of q is 2. So, minus 1. What am I saying? It's minus. Sorry, minus. So it's minus 1 plus 2. So minimum is, it's 1. Right? Minimum is 1. Now, let's look at max. A is positive. So since A is positive, max is A plus Q. Meaning it is... I made a mistake. Thank you. Oh, I didn't. It's minus 1. That's the minimum. So here, what is the maximum? A is 1. That's perfect. 1 plus, what is Q? It's 0. So it is 1. So what is maximum here? maximum is minus A, right? I mean, maximum is A plus Q. So what is it? A is 1. What is Q here? Q is 2. So our maximum is 3, right? This is to say the graph has shifted 2 units up, as you can see. Right, cool. Now what is the range? The range, remember, we said it says y is an element of minimum value, which is -1 to maximum 1. Here, what is the range? Here the range is y is an element of what is the minimum value? 1. What is the maximum? Maximum is 3. Right? So the equilibrium position of this graph, where it divides the minimum and the maximum, is 0. Right? But here it's 2. Can you see that? It's 2. Right, because as you can see, from -1, 0, 1. Here, from 1 is 2, 3. Hence, the equilibrium position is 2. Okay, so these are the things that you know. However, what is the period of this function? We said period is 360 degrees over b, meaning 360 degrees over 1. Therefore, our period is 360 degrees. What is our period here? Our period here is 360 degrees over, what is the value of b? Here it's 2. Right, here it's 2. So we have our period is 180. Now, what is our step if I am to plug this on a calculator to give me corresponding values? It will be 90 degrees by 1, by b, sorry. So 90 degrees divided by 1 equals 90. But for this, my step, remember, this step, this thing of step is for you to basically get your way around it. It's more important if you're in grade 10, or if you don't know these functions. So to get the step, it is 90 degrees over b. So for this one, when you sketch it in 45 degrees. It will help you because 90 by 2 is 45. All right? So let's go. Now we're going to sketch this. When we sketch this on your calculator, you will plug in f of x equals sine x, and then f of x equals sine 2x plus 2. What you're going to have, you're going to get something like this. Let me use it like this. So I'm just going to start it here. So let me call this one here -2 -1 0 1 2 3 4. I'm gonna call it y, and here it's going to be 90 180 270 360. Okay, 360. Okay, it's too long. Okay, now for your f of x equals sine x, you get x equals, let's try this horizontally. You can start with your 0 90, so 0 90 180 270 360. All right, so you will get the corresponding y value. When x is 0, you get 0. When x is 90, you get 1. When x is 180, you get 0. When x is 270, you get -1. When x is 360, you get 0. So here is it. 0 1 0 -1 1. Okay, 0. So here is it. Right? So this is your f of x. Now, let's look at your g of x. I'm going to try it with a different color. So let's look at g of x. G of x is sine 2x plus 2. And we said you have 0, 45, 90, 135, 180, 225, 270, 315 degrees, and then 360 degrees, right? So this is your x value, corresponding y value. What you have, when this is 0 degrees, on your calculator, if you were to use a table, 0 degrees, you will get 2. Yes, you will get 2. And then 45 would be 3. 90 degrees would be, I think, 2 as well. Yeah, I think 2 as well. 135 would give you 1. 180 would give you 2. Let me confirm. Let me confirm. Let me just use a table as well. Where's my table? Okay. So this is sine 2. Remember, guys, to put, especially if you're using KCU, to put your x inside the bracket, okay? And then this 2 is outside. I'm not going to use g of x. So I start at 0. I end at 360. My step is 45. Okay. All right, 180, it's 2. 225, it's 3. 270, it's 2. 315 is 1. 360 is 2. Right, let's plot this. 0, it's 2. 45 is 3. 90 is 2. And then 135 is 1. Here's 135 into 1. And then 180 is 2. 225 is 3 for sure. Yeah, it's 3. And then 270, it's 2. 315, it's 1. 360, it's So here is it. Okay. Oh, I skipped something. Yes. Where's that? 315. Okay, I'm fine. Oh, yes. I didn't skip anything. All right. Yep. All right. So let me remove this background. Okay. Do you now see? Look at it. In the domain for f of x, in the domain, so this is g of x. Yeah, this is g of x. And the black one is f of x. As you can see, for f of x in the domain 0 to 360 degrees, we have one complete cycle. Can you see that? This is one complete cycle, and look at it. What is the amplitude? This is the equilibrium position I was talking about. It begins at 0 and it has to end at 0. So the equilibrium position, the Q value is 0. It is that line that divides the minimum and the maximum in two equal halves. Can you see that? Look at it, this one here. It was shifted 2 units up, and that q divides this into equal halves. Can you see that? Again, don't confuse things. The amplitude here, it's still 1. Amplitude is still 1. Okay? Amplitude is still 1. So another way of finding your amplitude, you can say it's you have to be careful. You can say it's minimum minus, what is this? Maximum minus q. Okay? You can say it's maximum minus q, and that will still be okay. All right? Maximum minus q. Right. So again, as you can see, b here was 1. So this means in the domain 0 to 360, we have 1 complete cycle. But this one here, b was 2. Here's the first cycle. Here's the first cycle, and here's the second. Can you see that? The first cycle, the second cycle. Hence, we're saying the period is 180. It was telling you that the first cycle completes at 180 degrees. Indeed, it completes at 180 degrees. I hope this makes it easier for you. So what you do on the sine graph is what you do on the cosine graph. Right. So with that being said, it's a wrap, guys. See you next time, and bye-bye.